today's class. But before going to this particular class, definitely I would love to recapitulate what we have studied in our previous classes. Now, what we have revised, I just want to convey you within 4 to 5 minutes. Okay. First of all, हमने ये study किया है. We are going to discuss the chapter number 3, in which we have studied the classification of elements in periodic table. That means you have almost 118 elements, और उन सब के बारे में जानना बहुत मुश्किल था unless we need to arrange them. तो हमने उनको periods और groups में arrange किया है so that हम उनके बारे में information easily gather कर सकें. That's the first point. Secondly, we have studied about the IUPAC naming of elements greater than 100 atomic number. जिन elements का atomic number more than 100 है, you need to rename them with a proper IUPAC naming, and that is very important because that's definitely a question that would come in your exam point of view. All right, so ये 2-3 points I have shared with you. In the last class, I have started to teach you the trends in physical properties. Trends in physical properties means कि अभी हमने arrange तो कर लिया है अपने elements को in groups also or in periods also, but the point is how can we define their properties, like उनका melting point क्या है, उनका boiling point क्या है, और their atomic size or their atomic radii, है ना. So these all 4-5 properties, we have arranged them in the form of increasing order or decreasing order along the period or the group. Okay, and we have also studied the first one physical property, that is atomic radii. Am I clear about this? Now let's start with today's topic, that is the isoelectronic species. Okay, let's begin with the topic isoelectronic species. See, yesterday I have taught you about ionic radii. That means we have studied in that particular series that we have 2 different type of ions, है ना? The cation and the anion. Cation means the atom with positive charge, and anion means atom with the negative charge. This we have already studied. Now let's move to our next topic on the same series, isoelectronic species. This is a very super important definition, and examples are also important, quite obviously. So isoelectronic जो है, that is made up of 2 different words, iso and electronic. Electronic means you know very well, electrons that are over there, and iso means the same number. So if I want to define isoelectronic species, I would love to define it. The species which have same number of electrons are known to be isoelectronic species. I would repeat it again. The species with the same number of electrons are known to be isoelectronic. Now the question arises, we have defined it, but what is its actual meaning? हम इसको समझे कैसे? For example, we have O2 negative, we have F negative, we have Na positive, और we have neon. आपको पता है कि हमारा जो ऑक्सीजन है, that's atomic number is equals to 8. You know that now very well, that atomic number is equal to 8. 2 minus mean we have added 2 more electrons to it. I'm again repeating, whenever we are taking with the negative charge, that means we have been provided it with extra electron. That is, it has become an anion now. Anion means at any kind of atom, or I would say species, which have an extra electron surrounded with it. Okay. So basically, if I want to say O2 negative, the atomic number is 8 plus 2 electrons we have added, 10. Same as it is F negative, 9 plus 1 equals to 10. Neon already has 10 electrons. Na positive has 11 minus 1 equals to 10. Q, because this is a cation. Positive means we have removed 1 electron from it. Right? So these are all the species which have same number of electrons. So in the exam, you would be given 2 to 3 particular species like Na positive anion, F negative, O2 negative, or aluminium 3 positive, or beryllium, boron, and उनमें से आपको पिक करना है which are the isoelectronic species. Okay, so this type of question would definitely come in your exam, and I hope you have cleared the idea what do you mean by isoelectronic species. Okay, so that's all about isoelectronic species. Now let's move to our next topic. We have studied the atomic radii, the trends of atomic radii across the period and down the group. Same as it is, we are going to move with the second property, that is ionization enthalpy. Okay, so the second point, the second physical property is ionization enthalpy. Okay, let's move. Ionization enthalpy. Ionization enthalpy. Okay, the first point is what actually the ionization enthalpy wants to convey us. Ionization enthalpy की definition क्या है, क्या हमें बताना चाह रहे हैं. Then we would move with the trend. Okay, across the period increase हो रहा है या decrease हो रहा है. That's our second point. The first point is what's the definition of ionization enthalpy. Enthalpy means energy. So the ionization enthalpy is defined as energy required to remove the most loosely bounded electron from any atom in isolated state. Now, bache, I have defined it very well, but the point is what it's actually meaning. हमें energy चाहिए to remove the most loosely bounded electron from an atom in isolated state. Do not skip the topic isolated state. That means हमारे पास कोई एटम है जो सिर्फ और सिर्फ एक सिंगल फॉर्म में है, उसने किसी और एटम के साथ अपने आप को कंबाइन नहीं किया हुआ है. It has not bonded with another kind of atom. So that is known to be isolated state. For example, F2, fluorine, fluorine, that is not isolated state, but fluorine, that is isolated state. Okay, so please keep that in your mind, that ionization enthalpy is only valid for the atoms which have the isolated state. Am I clear? Now, we have told that suppose we have an atom named X and we have removed any kind of electron from it. So the energy that we need, energy required to remove electron from this atom is X positive plus E negative. That is known to be ionization enthalpy. Am I clear? Now, क्या मैं इसको ये define कर सकती हूँ that ionization enthalpies are my endothermic reaction? You have studied in your 10th class endothermic and exothermic. Endothermic किसको बोलते थे? Endothermic were those which need energy, है ना? And exothermic which release energy. That's quite opposite. So if I'm talking about ionization enthalpy, the endothermic, they need energy. You have also studied in your 10th class that all the energies in endothermic reaction are positive. Am I right? All the energies in endothermic reaction are positive. You must know that. Okay, please keep in your mind कि endothermic में जो reactions में energy होती है वो positive होती है, whereas in exothermic the energy difference is equal to negative. Okay, so I would love to say that all my ionization enthalpies, they are positive in nature. Okay. Okay, G. Now what else we need to study in this topic? Okay, quite obviously, क्योंकि these are the terms or these are the units of energy. So इसकी जो unit होगी that would be kilojoule per minute. Okay. So this is ionization enthalpy. Now, ionization enthalpy has so many different types, like as first ionization enthalpy, second ionization enthalpy, third ionization enthalpy. First ionization enthalpy we have already studied. This is known as first ionization enthalpy. That means कि हमें suppose फ्लोरीन से एक इलेक्ट्रॉन को रिमूव करना है, that is my first ionization enthalpy. Clear? Same as it is if I'm going to move with the second ionization enthalpy. That means I have to remove electron from the cation. है ना? Same as it is the third one. That means we need to remove electron from another cation. Okay. So there are so many different type of ionization enthalpy. Now the point here arises, which ionization enthalpy is higher in its unit. यानी इन तीनों ionization enthalpy में से which ionization energy should be high. So that is your query, that should be a topic arise in your mind कि इन तीनों में से ज्यादा कौन सी होनी चाहिए. So quite obviously the second ionization enthalpy is greater than first ionization enthalpy. अभी क्वेश्चन होता है why is it so? Why is second ionization enthalpy greater than first ionization enthalpy? To be very simple बच्चे, कोई भी cation में से इलेक्ट्रॉन को रिमूव करना is much difficult than its natural state. क्यों? क्योंकि अभी वो natural state में था, we have removed an electron very easily. Now it has in positive state. That means there is already a decline of electron. वहाँ पे अभी still electron की कमी है. Still there are less electrons. So why would we be happy to give another electron? है ना? So if I'm talking about second ionization enthalpy, that would be more greater. यानी हमें ज्यादा energy provide करानी पड़ेगी एक और electron को remove करने के लिए, because that's difficult. Same as it is, third would be more higher than the second, क्योंकि वहां पे और भी कम electron है ना? So this was the concept we have studied in ionization enthalpy. These two topics. Okay. I hope I'm clear with the topic. Now let's move with the trends. Yani we are going to see in our periodic table across the period and down the group, how is the trend observed? How is it increasing or decreasing? Okay. All right. Let's move to our next topic. Okay, let's move with the table. We have lithium, sodium, potassium, beryllium, magnesium, and same as it is fluorine, chlorine, bromine, iodine, helium, neon, argon, krypton, xenon, है ना? So the first point is बच्चे, हमारे पास two type के elements हैं, those which are present in the extreme left and those which are present in the extreme right direction. Okay. In the right, we have noble gases. You have must understood about the noble gases. In our last 2-3 lectures, we have talked so much about noble gases. है ना? किसको बोलते हैं noble gases? Suppose I'm talking about neon, argon, krypton. Noble gases are those which have completely filled subshell. Am I clear? So completely filled subshell means, suppose I'm talking about neon, that is 2s2 2p6. 2p6 means its electronic configuration is 2p6. All the p orbitals have been completely filled. Now tell me one thing, whenever it is completely filled, for it, would it be easy to remove an electron? अगर इसके पास पहले से ही सबशेल इसका completely filled है, तो क्या इसके लिए ये easy रहेगा कि मैं अपने आप कोई भी एक इलेक्ट्रॉन डोनेट कर सकूं? Would it be easy for this? Definitely no. जब इसके पास already electrons completely filled हैं, so for removing any kind of electron from this subshell, we have to provide much more high energy, है ना? हमें बहुत ज्यादा energy provide करानी पड़ेगी ताकि we need to remove an electron, because this is already completely filled. Hence, these are something which have the maximum ionization enthalpy, है ना? Same as it is if I'm talking about my lithium, sodium, potassium. Suppose I'm talking about my sodium. Sodium का जो number है, that is Z equals to 11. Atomic number 11 है. यानी 1s2, 2s2, 2p6, 3s1. So 3s1 there is only a single electron in its s orbital. That means यहाँ से एक इलेक्ट्रॉन को रिमूव करना would be much easier, क्योंकि इसके पास दोनों ऑप्शन है कि या तो एक इलेक्ट्रॉन को लेके कंप्लीटली फील्ड में चला जाए या एक इलेक्ट्रॉन को रिमूव करके अपनी नोबल गैस वाली कन्फिग्रेशन अचीव कर ले, दैट इज 1s2 2s2 2p6 नियो, है ना। तो इसके पास दोनों ऑप्शन है, सो इट हैज मच पॉसिबिलिटी दैट इट वुड इजीली रिमूव इट्स इलेक्ट्रॉन, ओके। सो these have the minimum ionization enthalpy and those have maximum ionization enthalpy. So in this way I can exemplify that the ionization enthalpy across the period keep on increasing from left to right. यानी जब भी हम पीरियड में लेफ्ट टू राइट मूव करते हैं, माय आयनाइजेशन एनर्जी वुड कीप ऑन इंक्रीज। एम आई क्लियर? Okay, within 2 to 3 minutes I would recap, I would cover up this topic and then we would have your doubt session. All right.